Hello and welcome to SudoKanard. Here is a Mathrax Sudoku puzzle that I created a long time ago that I had reserved for this very occasion, this round of the Sudoku Grand Prix. And from the feedback I've had, this puzzle caused a lot of grief. And it's really not that hard if you look at stuff in a correct order, and that's obviously where the difficulty lies. So where should we start? So I tried to show you what was the intended solving path. So 16 as a product can be either 2, 8 or 4, 4. So all of those cells must be among 2, 4, and 8. But this wouldn't be 8 with a sum of 7. This will never be -1, so this can't be 8, this can't be 2. So that's something. This 16 sum is either 7 plus 9 or 8 plus 8. And something to understand is that there is a 4 in one of those two cells, a 4 in one of those two cells, and therefore we have all 4s globally located for the first 2 rows, and the 4 on the 3rd row must be here. And this -5 says that 9 must be here to satisfy a difference of 5. And we can eliminate 9 from those cells, and we can eliminate 7 from those cells. So that's for a start. And the interesting thing I see here is that 9 is in one of those two cells, so there's no 9 here. And obviously 9 won't be here. So 9 must be somewhere in here. So 9 is not here. If you try to put 9 here, then this is 7 and this has to be 0, which is not allowed. So the 7-9 pair is on the other diagonal of this 2 minus clue. Right. Oh, sorry, something with my battery. Right, that's better. Now, let's have a look at digit 8. We know that there's an 8 here. So 8 won't be here. 8 won't be here. So 8 in this box is either here or there. And this can't be 8. That's a 4. That's a 2. Oh, sorry. That's a 4 as well. What did I do? So that's a 4. And we can remove 4 from those cells. And this has to be a 3 to satisfy this. Then, what was the next question? The next question was about digit 5. We know that 5 won't be here, because then this would have to be 3 or 7. Same 5 can't be here. And if I try to put 5 here, then this is 2, and there's no value for this. It would have to be a 4. So 5 can only be here. And looking at this division clue, well, both results must be the same. The only way to satisfy this is to have a 5 here and a 3 there. A way of seeing that is that the ratio must be 5 to 3, and the only way to do that is to have a 3 and a 5. And this will play a part. 3 and 5 will have to be here somewhere at some point. Now, what option remains? So now 5 and 2 are not on this diagonal, and 2 can't be here because it would need a 4 here. So 2 is here. That's an 8, that's a 6, and that's a 1. And that's 8, and that's 9, 8, 7, and 8, which resolves a lot. So that's the initial logic. Next, let's have a look at what happens, say, on this row. The candidates here are 2, 6, 7, and here 2 won't be here because it would put a 7 here. So the candidates are 4, 6, 7. And here the candidates are 1, 2, and 9. Here the candidates are 6 and 9, but we know that there's a 9 somewhere here, so that's actually a 6. There's a 9 here, 4 must be here, and that's 1 or 2. Let's move on to this 13. So the options for 13, we don't have an 8. So the options remaining are 4 here with a 9 there, and 7 here with a 6 there. And those are the only ways of satisfying those sums of 13. This now must be 1 or 4. And the question you may ask is, where does 5 go in this box? 5 won't be on this diagonal. We would need a double 5. And 5 won't be in the diagonal of this 11, as it would require to use a 6. So 5 must go here. Next is, where does 1 go? 1 won't be on the 11. We won't put 10 on the other side of the diagonal. So 1 must be here with a 9. But this diagonal can't use a 9. So 1 is here with a 9. That's 6, that's 7, that's 4. Next, we see that 8 and 7 won't be here. So 8 and 7 will be here with a 3 and a 4. So that's a 2. That's 8, that's 3. And 7 and 4. So that's not 7, that's not 4, not 7, so that's not 2, that's not 1. So now this diagonal can only be 9, sorry, can only be 2 and 7, and this one, 7 is not here, so that's a 2, 6 pair, and that's a 4, and that's the 9, and we get the 1 here. And that's the end of part 2 of this. So 3 is not here, 5 is not here. Where do we look next? Well, this is a good place to look. Well, first you see it by Sudoku that we have a 2 here. And then what? With this 6 and this 6, you see that there must be a 6 somewhere. So the question will be, where does 6 go? So what are the options? This row needs a 1, 6, and 8, so this is 1 or 6. And if I try to put 6 here, then the difference is 5. Is 4, sorry, so it could be 1 and 5. That works. And I feel like I'm overlooking something. So what could it be? Is it? Yes, it's about digit 9. 9 is somewhere here. So I said that it would work, but actually it wouldn't. Because if I put a 6 here, then that's 9 and 1. And then this minus condition is not fulfilled. So 6 can't be here, so 6 is here. 9 is somewhere here, but putting 9 here, that would make a difference of 7, and no digit would suit this position. So 9 is here. The difference is 3 after all, so this is 5. There's no 6 here. We get this 9 and this 7. Those are 1 and 3. Here, that's 1, 3, and 7, so 7 is here. That's 1, 3, and 5. Here we have, that's 3 and 6. Here we have 4 and 5. But 5 here won't work, because if I put a 5 here, then the product here is a multiple of 5, and the product here can't ever be a multiple of 5. So that's a 4 and that's a 5. Which means that those digits are in a ratio of 2, and it won't be 1 and 2, it won't be 4 and 8, so there must be 3 and 6, and namely that's 6 here and 3 there to have a product of 12. That's 3, that's 6, we get 1, 5 here, 1, 3 here, and 3 here, and 2 there. And that's the end of that major part 2 or part 3, if you wish. And now I think that looks completely unlikely that all this 5 by 5 square can be resolved with just that clue. And I must tell you, when I created this puzzle, that looked very much like a miracle. So how do we do that? Well, this 3 puts the 3 here, so 5 is here. And we see that 1 and 2 are here. 1 and 2 are here, so 1 and 2 must be somewhere in this square. And you see that 1 and 2 can't be on the same diagonal, because that would make a sum of 3 and the other diagonal would never work. So what else can be said? There's a 5 somewhere here. And it's about digit 6, I think. Not sure about that. Here I need 7, 8, 9. Well, what will I find? I must recall what digit makes it really, really simple. But this is where my memory fails. There's a 5 somewhere here. So the digits here are 1, 2, 8, and 9. So this is 2 or 9. This is 1, 2, 9. This is, no, sorry, 1, 2, or 8. This is 1, 2, or 9. Here the digits are 1, 2, 5, and 6. And actually, 5 is here. So this is 1 or 2. And this is 1, 2, or 6. But then we say that 1 and 2 can't be on the same diagonal. So knowing that this is 1 or 2, this has to be 9. So the sum is 10 or 11, and 6 can't make any of those happen. So this is not 6, and 6 is here somewhere with the 5. That's a 2. And this is not 1 or 2, that's 8. So finally the sum is 10, and this is 2, and this is 1. And the rest should be plain Sudoku. So this is 7, no 7 here. Here I need 4 and 6, so this is 4, this is 6. Here I need 8 and 9, so this is 9, this is 8. That's a 1. This 2 resolves the 2, 6 square here. That's 5, that's 6, that's 5. This here is a 9. Here I need 8 and 3, so that's 3 and 8. No, sorry, that's 3 and 7. This 9 makes this 8, 9. That's 1, that's 8. Here I need 4 and 7. And that's 1, and that's 2, and that's it. So I'm very proud of this Mathrax puzzle. And I really feel sorry that it caused so much trouble to solvers. And I hope that this walkthrough will show you that it really wasn't that hard, but the matter is always the same. Look at the right place at the right time. And I know as a solver how difficult that can be. So thanks for watching this video. Thanks for taking part in this Grand Prix round. And see you soon on SudoKanard.